Arc flash is a dangerous electrical event where high-energy arcing escapes its intended path. This can lead to severe burns, hearing loss, and even death. When calculating arc flash hazards, you need certain information. Firstly, the available fault current. This is the maximum current that could flow through the circuit under fault conditions. Secondly, the arc flash boundary. This is the distance from the electrical equipment where the arc flash hazard extends. Thirdly, the personal protective equipment, or PPE category. This determines the required level of PPE to protect workers from arc flash. The compliance process involves several steps. 1. Identify electrical equipment. Determine which machines and equipment are subject to arc flash hazards. 2. Collect data. Gather necessary data on available fault current, arc flash boundary, and the upstream electrical feed. 3. Perform an arc flash analysis. Use software or consulting services to calculate arc flash hazards for each piece of equipment. 4. Establish PPE requirements. Determine the appropriate PPE category for each equipment based on arc flash calculations. 5. Document and implement. Create written arc flash hazard analysis documentation and implement required PPE and safety procedures. Viewing windows and external control access ports can reduce arc flash explosion risk, but they are not enough for full NFPA 70E compliance. They provide limited protection and should be used with proper training, PPE, and engineering controls. Regarding the upstream feed, compliance generally falls on the organization operating the equipment, not the manufacturer. However, communicate with customers and request relevant upstream feed information. While the customer is responsible for compliance, electrical supply vendors can provide guidance and support in understanding requirements and selecting equipment. All employees exposed to arc flash hazards should receive proper training and be aware of safety procedures. Several resources are available, including NFPA 70E standard for electrical safety in the workplace, IE 1584 standard for performing arc flash hazard calculations, the EPRI guide for arc flash hazard analysis, and online arc flash calculators. Available fault current is the maximum amount of current that the electrical system can deliver under short-circuit conditions. It's a critical parameter in arc flash calculations because the higher the fault current, the greater the potential arc flash energy. Determining available fault current typically involves consulting with the utility company that supplies power to the facility or using specialized software and tools to perform short-circuit studies. These studies analyze the electrical distribution system, taking into account the impedance of transformers, conductors, and other components to estimate the maximum fault current at various points in the system. The arc flash boundary is the distance from exposed energized electrical conductors or circuit parts within which a person could receive a second-degree burn if an arc flash occurred. This boundary is calculated based on the available fault current, the clearing time of the overcurrent protection device, and the working distance. The calculation is intended to define a safe zone around energized equipment, and personnel working within this boundary must wear appropriate PPE. The further away from the source of the arc flash, the lower the incident energy and the less severe the potential burns. PPE is essential for protecting workers from the hazards of arc flash. The selection of appropriate PPE depends on the incident energy level calculated for a specific task and equipment. PPE includes flame-resistant clothing, such as shirts, pants, and coveralls, as well as arc-rated face shields, safety glasses, gloves, and footwear. The level of protection provided by PPE is measured by its arc rating, which indicates the amount of incident energy the clothing or equipment can withstand without causing injury. NFPA 70E provides guidance on selecting the appropriate PPE category based on the calculated incident energy. Identifying electrical equipment involves creating an inventory of all electrical equipment in the facility that could potentially be subject to arc flash hazards. This includes switchgear, panel boards, motor control centers, transformers, and any other equipment where employees may be exposed to energized conductors or circuit parts. The inventory should include details such as the equipment's voltage, amperage, and location. Collecting data involves gathering information about the electrical system and equipment that is necessary for performing arc flash calculations. This includes the available fault current at the source, the impedance of transformers and conductors, the settings of overcurrent protection devices, and the working distance. Data can be obtained from equipment nameplates, electrical drawings, utility companies, and through on-site measurements. Performing an arc flash analysis involves using the collected data to calculate the potential incident energy and arc flash boundaries for each piece of equipment. This can be done using specialized software such as SKM Power Tools, ETAP, or Easy Power, or by hiring a qualified electrical engineer to perform the analysis. The analysis takes into account various factors, including the available fault current, the clearing time of the overcurrent protection device, the working distance, and the equipment configuration. Establishing PPE requirements involves determining the appropriate PPE category for each task and equipment based on the arc flash calculations. NFPA 70E provides tables and guidelines for selecting the appropriate PPE based on the calculated incident energy. The PPE category specifies the minimum arc rating of the clothing and equipment that must be worn to protect workers from the potential hazards of arc flash. Documenting and implementing involves creating a written arc flash hazard analysis documentation that includes the results of the arc flash calculations, the PPE requirements, and the safety procedures that must be followed when working on or near energized equipment. The documentation should be readily available to all employees who may be exposed to arc flash hazard. Implementing the documentation involves training employees on the hazards of arc flash, the proper use of PPE, and the safety procedures that must be followed. It also involves ensuring that the required PPE is readily available and properly maintained. Viewing windows and external control access ports can provide some degree of protection from arc flash hazards by allowing workers to operate equipment from a safe distance. Viewing windows allow workers to visually inspect equipment without opening the enclosure, while external control access ports allow workers to operate controls without exposing themselves to energized parts. However, these devices are not a substitute for proper arc flash training, PPE, and engineering controls. The burden of compliance with NFPA 70E generally falls on the organization that owns and operates the electrical equipment. This means that the organization is responsible for conducting an arc flash hazard analysis, establishing PPE requirements, training employees, and implementing safety procedures. However, machine builders also have a responsibility to provide information to their customers about the potential arc flash hazards associated with their equipment. This information should include the equipment's voltage, amperage, and short-circuit current rating, as well as any specific safety precautions that should be taken when working on or near the equipment. Electrical supply vendors can play a role in helping organizations comply with NFPA 70E by providing guidance and support in understanding the requirements and selecting appropriate equipment. Vendors can also provide training and consulting services to help organizations conduct arc flash hazard analyses and develop safety programs. Training and awareness are essential for protecting workers from the hazards of arc flash. All employees who may be exposed to arc flash hazards should receive proper training on the hazards of arc flash, the proper use of PPE, and the safety procedures that must be followed. Training should be conducted by qualified instructors and should be tailored to the specific tasks and equipment that employees will be working on. Several resources are available to help organizations comply with NFPA 70E, including the NFPA 70E standard itself, which provides detailed requirements for electrical safety in the workplace. IEE 1584 is a standard for performing arc flash hazard calculations. The EPRI Guide for Arc Flash Hazard Analysis provides guidance on conducting arc flash hazard analyses. Online arc flash calculators are available to help organizations estimate the potential incident energy and arc flash boundaries for their equipment. When considering upstream feed, it's important to understand how the electrical power is supplied to your equipment. The upstream feed refers to the electrical distribution system that provides power to the equipment in question. This includes the utility power source, transformers, switchgear, and other components that make up the electrical pathway. Knowing the characteristics of the upstream feed, such as the available fault current and voltage, is crucial for accurately calculating arc flash hazards. In cases where the machine builder doesn't have direct control over the upstream feed, it's recommended to communicate with the customer to obtain this information. Customers typically have access to electrical system studies and documentation that can provide the necessary data. Sharing this information allows the machine builder to assess the potential arc flash hazards and provide appropriate safety recommendations. Regarding electrical supply vendors, it's important to view them as a valuable resource for arc flash safety. These vendors specialize in electrical equipment and can offer expert advice on selecting components that enhance safety and minimize arc flash risks. They can also assist with arc flash studies, PPE selection, and training programs. When choosing electrical supply vendors, consider their experience, expertise, and commitment to safety. Look for vendors who are knowledgeable about NFPA 70E and can provide guidance on complying with the standard. In addition to providing equipment and services, electrical supply vendors can also help educate your team about arc flash hazards and best practices for electrical safety. Proper training and awareness are fundamental to preventing arc flash incidents. All employees who work on or near electrical equipment should receive comprehensive training on the hazards of arc flash, safe work practices, and the proper use of PPE. Training should be tailored to the specific tasks and equipment that employees encounter. It should cover topics such as identifying arc flash hazards, understanding arc flash boundaries, selecting and using appropriate PPE, and following lockout-tagout procedures. Regular refresher training is essential to reinforce knowledge and ensure that employees stay up to date on the latest safety practices. Creating a culture of safety within your organization is critical to preventing arc flash incidents. This involves promoting open communication, encouraging employees to report potential hazards, and recognizing and rewarding safe behavior. By investing in training, promoting awareness, and fostering a safety-conscious culture, you can significantly reduce the risk of arc flash incidents and protect your employees from serious injury or death. Firstly, the organization operating the equipment is generally responsible for arc flash compliance. Secondly, communication with your customer can provide necessary upstream feed information. Thirdly, electrical supply vendors can guide understanding requirements and selecting equipment. In addition, the upstream feed is the electrical distribution system that powers the equipment, and knowing its characteristics is crucial for accurate calculations. Furthermore, electrical supply vendors should be viewed as a valuable resource for arc flash safety. After that, comprehensive training should be provided to all employees working with electrical equipment. And lastly, a culture of safety is essential to prevent arc flash incidents. When it comes to identifying electrical equipment subject to arc flash hazards, start by creating a comprehensive inventory of all electrical equipment within your facility. This includes everything from main distribution panels to individual machine control panels, transformers, and motor control centers. Be sure to document key information for each piece of equipment, such as its voltage level, current rating, and location within the facility. This inventory will serve as the foundation for your arc flash risk assessment. Next, gather data on the available fault current at the main power source. This is the maximum amount of current that the electrical system can deliver under short-circuit conditions. You can obtain this information from your utility company or through an electrical engineering study. The available fault current is a critical factor in determining the severity of a potential arc flash event. Also, determine the characteristics of the overcurrent protection devices, such as circuit breakers and fuses, that protect the electrical equipment. These devices are designed to interrupt fault currents and limit the duration of an arc flash event. Collect data on their trip curves, interrupting ratings, and settings. This information is essential for calculating the incident energy and arc flash boundaries. Also, consider the working distance, which is the distance between a worker's face and chest and the potential arc flash source. This distance affects the amount of heat energy that a worker could be exposed to during an arc flash event. Typically, a working distance of 18 inches is used for panel boards and 36 inches for switchgear. To perform an arc flash analysis, you can use specialized software tools that automate the calculations and generate reports. These tools require input data on the electrical system, equipment parameters, and overcurrent protection devices. The software then calculates the incident energy, arc flash boundary, and required PPE for each piece of equipment. Alternatively, you can hire a qualified electrical engineer to conduct the arc flash analysis. An engineer will have the expertise to perform the calculations, interpret the results, and recommend appropriate safety measures. When establishing PPE requirements, the selection of PPE depends on the calculated incident energy level for each task. NFPA 70E provides tables that classify PPE into different categories based on their arc thermal performance value, or AP, which is a measure of their ability to withstand heat energy. The higher the incident energy, the higher the AP rating required for the PPE. PPE includes flame-resistant clothing, such as shirts, pants, and coveralls, as well as arc-rated face shields, gloves, and footwear. It's important to select PPE that is appropriate for the specific task and that fits properly. As part of the documentation and implementation process, create a written arc flash hazard analysis report that summarizes the findings of the analysis, including the incident energy levels, arc flash boundaries, and PPE requirements for each piece of equipment. This report should be readily accessible to all employees who work on or near electrical equipment. Secondly, develop and implement an arc flash safety program that outlines the procedures and practices to be followed to protect workers from arc flash hazards. This program should include training, PPE requirements, lockout-tagout procedures, and other safety measures. Also, provide regular training to employees on arc flash hazards, safe work practices, and the proper use of PPE. Training should be conducted by qualified instructors and should be tailored to the specific tasks and equipment that employees will be working on. Viewing windows and external control access ports are considered risk reduction methods, not complete solutions. Also, it's recommended to communicate with your customer to request any relevant information they may have on the upstream feed. Electrical supply vendors can provide guidance and support in understanding the requirements and selecting appropriate equipment. Lastly, training and awareness are crucial for ensuring that employees understand the hazards of arc flash and know how to protect themselves. There are resources available such as NFPA 70E, IEE 1584 and EPRI Guide for Arc Flash Hazard Analysis to learn more.